Good morning and welcome to Frank's School. Okay, windmills, parts. This is the second video I'm devoting to it, and I want to deal with parts. Now this isn't going to be pretty because I can't draw, but I'm going to do the best I can. I'm going to start from the bottom up, and then with the parts I'll come down. The windmill that I'm going to build, the first one anyway, is three-legged. Now if you look at it in plan, then it's going to be sort of like that. Here's the legs. This is a tetrahedron. And actually, if you looked at it, this is in elevation. If you looked at it in plan, in other words, from the top down, it would look the same. I guess I could... yeah, three triangles tipped together like that. Uh-oh, here comes a cat. And on a base. So the base is also the same. So there's four triangles that are identical. Three sitting on a base. But anyway, think about it as elevation. You're looking straight at it. And on top of this, on top of this, oh, and I have a triangle inside it to stiffen it up, make it stronger. He'll be back up. On top of this, then, I have a truncated pyramids, you might say. There's three of them, and it's braced like that. So that will sit on top of this. Why I did it that way is because I need to have access to the sweep. Well, let me go on with this. This up here is the cap. So on the cap, there is well. Now I'll explain as I'm going. I need two bearings. The wind shaft, whoops, it doesn't have to go that far. The wind shaft sits in the bearings. Out here is the sweep, it's called. There's where the sails are. And there's a brake wheel. I think in my, the brake wheel is usually here. It's usually real big. And there's a wallower here, main shaft. I'll go through these in a minute. And then out here, out of wood, we just framed, so far we just framed it this way. But you'll often have here some kind of a fan, it's called a fantail. Boy, that's ugly. All right, well, in any case, let me go down through these terms. Cat, don't cause trouble. Oh, boy, that's ugly. Okay, the sweep is it's either half of it or all of it. I'm not sure, but it's the part that goes around like that. That's called the sweep. On the sweeper sails, which I suppose in a way I could draw them. Now I'll get so confused if I try to do this. They'd probably set in there sort of like that, I think. Anyway, there's sails, and even if they're out of wood, like in Germany and Holland, it's no wonder. I mean, it's so cold to go up there and adjust the sails in winter or stormy weather. They cleverly developed a technique that's like Venetian blinds in a way, so that you can open and close shutters like Venetian blinds to control the speed. But mine is going to be cloth sailed. Anyway, those are the sails. These are called the wind arms, and what I'm going to do first is I'm going to have them go the whole way through. But sometimes they're mortised into the wind shaft. For one reason, you often, that long of a piece of wood is not available and hard to work with and stuff, I guess. But in any case, ours are going to be continuous. So those are wind arms. Also sometimes called spars. And that term spar, if you know it at all, you probably think of it in terms of a sailing ship. Well, windmills and sailing ships are related. In many ways they're related, and I have done very little sailing, so I don't get too much help on that. All right, anyway, there's those. Now this is called the wind shaft, and it takes the power into the cap. There's a cap. Now let's see, and it's got to be mounted in bearings. There's got to be bearing, and I still am not ready to explain completely why this isn't level. Why is it always tilted? There are some reasons for it, and enough reasons that even though I didn't completely understand it, I decided that's what I would do. Partly to make sure I could do that, But now in the little tiny high-speed windmills out west, they usually go level. It's so much easier to build them when this is a right angle. But the older ones weren't. So the bearings, the brake wheel is right there, and I still don't have it quite figured out how I'm going to put a brake on this. But a brake, I think there was usually something that clamped the entire wheel, but it was geared. It's called a brake wheel, but it's a gear, and that gear, it might be back here, it might be there, but it drives a smaller gear called a wallower, and the wallower is connected to the main shaft. There it is, and takes the power down then to whatever machinery is going to be driven. The fact that that's not at a right angle, as I say, it really makes it kind of tricky. Now we've dealt with that by using a universal joint right in there, but in the old windmills they didn't do that. Their gearing was wooden pegs meeting wooden teeth meeting wooden pegs, and they could slide. I don't know if I can show this with my fingers, but you didn't have to actually have it at a perfect right angle. So in a way the wooden gears were better, easier that way, although massive. I may eventually do that. Now this whole cap turns, and what it turns on, and this is usually bigger than that, that's called a curb. And then out here, it doesn't have to be in the same line as the wind shaft. It doesn't, but anyway, this is called a fantail. If the wind itself is going to, like a weathercock on a barn, if the wind itself is going to keep adjusting the windmill into the wind, it's a fantail. But sometimes it's all too heavy for a fantail to deal with it, in which case there's a second little windmill here to drive a gear to drive the whole thing back and forth around. Or, and what we may do is put a long pole on here, and it's more complicated than I really can draw here. But this pole, you push it around. That's called a tail pole. And you actually get out there physically and push the thing around to adjust the windmill into the wind. Now, as I say, this is a cap. Sometimes there's mechanical advantage there. They'll have posts in the ground with a block and tackle. But one of the things about this is you kind of want this track, whatever it is, to be level. And if your windmill is sitting on a hillside, well, a hillside, like Threelegged windmill doesn't matter too much that way because it's just not that hard to level it up. But with the tail pole, that's a problem. You basically, that may be one of the reasons that windmills tend to be put right on top of hills, not partway up the hill. I mean, you always think, well, it's because it's most windy up there at the top. Yeah, but it's also real nice to have it on level ground. All right, now guy wires. There's wires. I don't know what. There's probably a better name for it, but in the kind of windmill that I'm going to build, the wind shaft goes out past the sweep, and then the guy wires keep the spars, the wind arms from blowing back, and they go also from sail to sail to sail in this line. As I say, there's probably a better name for it than guy wires, but that's all I know. Actually, I think on this one that I'm going to try to set up on Sunday, I may use clothesline. I was going to use wires with little what are they called? Turnbuckles. Little turnbuckles to get the tension right. But I think that might be a little expensive. I'm not sure how I'm going to do it. Well, I'm probably forgetting something. I'm sure I am. This I should maybe tell you. I found that it's between 7 degrees and 15 degrees, how much you tip it. Lower degrees, percent. Lower percent if the wind isn't too strong in that area. Steeper if the wind is stronger. And why it's tipped like that? One thing, you don't want to hit your base, your tower. Another thing, I think there's something to do with the way the wind comes over the top that is more efficient. But we'll see. Anyway, when I go out and film, I'll be showing these parts in what I intend to build. And I think I'll probably do that tomorrow. Bye for now.